Hello guys, this is just going to be a quick video to show you the first attempt at trying to 3D print the little quick hitch mechanism that we designed in one of the other videos. So it's pretty simple. It's based on this little motor or this little cam on it, and as the motor rotates, the other half of the hitch is just supposed to move in and out and catch in the pins on our bucket here. So this is the first attempt at printing it, and as you can see from all the little mods that I've been doing to it, it's not just turned out exactly as intended. The front bit isn't too bad. We can get it in there and get a hold of the bucket without much difficulty, but the positioning of the motor is far too low, so I don't really need to put the motor all the way in. But when you get control of it, you can see that on the front there is maybe okay, but on the back here we are already sitting on the motor. So this part of the bucket is hitting the motor, so that obviously won't work, and that means just that we need to extend the distance between this pin and sort of the line going across where the motor is well, let's say parallel to the two pins here. So it's just to make this a little bit taller really. So that is not a major issue, and we can do that. So other things, this part here was too tight, so I've filed a good bit off it now. But if I take this out, make it a bit easier. So you have this piece on the back that is supposed to go on there, that holds the motor, or well, it's supposed to prevent the motor from rotating, because there's this little keyed section sticking out here. That key sits on top of the motor so that the motor can't rotate once it's in here. So we have that section on there. That's held in place by the pins on the actual machine itself. So when we get the pins through there, that bit obviously can't spread out. So it's held by the pin. And then we have this piece that goes on over here, but it's way too tight, so the gap between these two sides is just nowhere near wide enough, so we were never going to get a nice smooth rotation. So what I've done is extend the gap here and just put a little, like basically a little cylinder, a little washer type idea just there, so that the only contact between these two mechanisms should be a small washer sized contact surface just where it meets at the two sides of the pin there. So that is one issue that has had to be dealt with. Because of that, when I was trying to make these modifications, I broke this piece off, so it did seem to be rotating fine. This piece was moving in and out, but I couldn't really get a proper test on it to see would it grab the back here properly, because we can't get the motor down far enough. So with the motor in, this is sitting up around about here, so it's never going to actually grip onto the rear. So the way it is without the motor, obviously we can get a hold of the rear of the bucket. It's not a problem. Well, not easy to do, but we can get a hold of the bucket without any issue, but the motor itself is preventing us getting down far enough to do that. So this is kind of an example of you do your first print, and you know it's hard to get all the dimensions perfect in the very first run. So you can see I've had to make quite a few modifications to get things to fit anywhere really on this part. So quite a bit. The pin diameter, I don't know, maybe I was trying, or maybe I'd planned to use a different pin and I've just forgotten what pin that was, but this pin diameter was far too small to fit over these pins. That was never going to work, so I had to file that out to get it down either side of the bucket. I had left this too wide, so I had to file that down. And not only are you having to make sure your dimensions are close enough so that they'll actually fit, But then when you actually print it, it's highly unlikely that what you have on the computer, the dimension you have on the computer, is going to be exactly what you are going to see from your finished product. It's probably going to be a little bit wider, or maybe a little bit narrower. It's just, there's always, because we're sort of adding material, and yes, we harden the part where the ultraviolet from the screen is getting on, but then when you take it out, there's also slight little bits around that, so it's never going to be 100% accurate. And because we are working on such small parts where the tolerances are like fractions of a millimeter, obviously we're going to have problems with it. So sometimes you get lucky and the first print is perfect, but more times than not, this is the way you end up. You end up with your first sort of prototype piece. You end up filing little pieces off, figuring out where you need to make the changes to your model, and then you reprint it. So even though this broke, it's not really a big deal, because I would have had to reprint this anyway. This mechanism here was never going to be great, because it was stretched across here. There was always going to be friction, and that was always going to cause trouble for us. But this is an example of what you commonly have to deal with when you're trying to 3D print things, so you can kind of expect this kind of thing. But I just thought I'd show you this first attempt at it. I've made the changes to the model, and I'll 3D print another set of pieces, and we'll see if that works. Hopefully it works the second time round. So that's all I have for this video. Thanks very much for watching.